Alrighty. Hello, everyone, and thanks for coming. Welcome to Monash DeepNeuron's Applied AI seminar. We will discuss how AI is used to solve real-world problems. We'll be exploring how some of our industry partners have re-innovated frontline AI technologies to achieve great change and impact in businesses. Thank you all for coming. My name's Liz, and I'll be your MC for the first part of the night. Before we begin, I'd like to acknowledge the traditional custodians of the various lands on which we are gathering from today, and the Aboriginal and Torres Strait Islanders people participating. I pay my respects to the elders past, present, and emerging, and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Victoria. So about us. As a student team, our mission is to empower students and researchers through ethical, hands-on, artificial intelligence and high-performance computing research projects. We partner with researchers from various fields to design custom AI or HPC solutions. We love educating anyone interested, regardless of experience, in the world of HPC and AI, with some workshops and training sessions. Some of our deep learning projects include microfluidics, which looks at using deep learning to improve male fertility outcomes, and microscopy and deep, which utilizes cell features to reduce manual image sorting in drug discovery. Other projects also include building a chess reinforcement learning agent and an AWS deep racer model. Our HPC team are also working on a drone photogrammetry project, which aims to parallelize the photogrammetry pipeline and create a scalable cloud-based solution. They will also be competing in the ASC Student Cluster Competition later this year. External to our project teams, we also have a strong marketing and industry portfolio. Their work includes the recent HER campaign, AWS workshops, and the 2020 AI Features Q&A. So tonight, we'll be hearing from 3 speakers from industry who will present how they have been using AI in their work. First, we'll hear from Dr. Ali Akbari from KPMG, and then Dr. Adam Makarucha from IBM, and to conclude the night, Andrew Underwood from Dell. After each speaker will have a Q&A, so please pop your questions in the Zoom seminar Q&A function. At the end of the entire night, after all the presentations are completed, we'll have more time for Q&A and networking. Okay, great. So our first speaker of the night will be Dr. Ali Akbari. He is a director in KPMG Innovation, Solutions and Ventures and joined the firm in 2020 as an artificial intelligence capability lead. He has been in the IT industry since 2000 and has been focusing on practical applications of AI and ML in real-world problems and operationalizing them at scale following completion of his PhD in 2006. Working in Japan and Australia and delivering projects across the APAC region, he has a diverse experience across different sectors, including manufacturing, health, finance, and the public sector. Ali specializes in unstructured data and image processing, risk management, and real-time decisioning using a range of AI and ML technologies. Thank you, Dr. Ali. Please take it away.
Thank you, Elizabeth, and thank you for having me on this call. Hello, everyone. My name is Ali Akbari, and going to talk a bit about future of AI and how we are applying AI at the moment in the industry. I just shared my screen. Just let me know if there's any issues. Otherwise, I assume it's working and going ahead. Give me a second. All right. Well, thanks to Elizabeth, you already have a good introduction. So I will just skip the first slide about myself. I quickly jump into it with having a look how COVID-19 impacted adoption of AI across the industry around the globe. So I think you can guess, COVID-19 made a lot of changes in our lives and pushed us to become more and more relying on living and working in the digital world. And industries, of course, they started adopting more and more of AI and machine learning capabilities in order to assist the businesses in this new situation. So these results are based on a study done by KPMG in year 2020 and then 2021, just earlier this year. You can see across 7 different industries, when we surveyed over 900 different IT decision makers and senior executives who have some role in the area of AI, and they have a moderate awareness of how AI is being used in their organizations. We can see, for example, at the top of the list in the industrial manufacturing, about 93% of them have confirmed that they are already using a part of in part of their processes and organizations. They have AI being functional. And if you compare, for example, here at the top, we have great improvement in some of these industries. If you just compare, for example, in the financial services, we had a jump of 37% compared to the last year. So we see that the adoption of AI is actually skyrocketing across different industries. And of course, we need to be a bit more aware of how are we going to apply it and consider the other side effects that might come along with it. To have a bit more interesting look into what may have come up in the future, we can also have a look at work that was done in collaboration between KPMG and a 3A institute from Australian National University last year, looking into discussing with the SMEs and trying brainstorming and predicting what can come up in the next 20 years. This is based on looking back in past 20 years, our world was very different. Like right now, we are very used to having our intelligent assistants on smartphones or in our home. But back then, we didn't have even this sort of smartphones in our lives. So if we look back and then try to project and predict in the future, we came up with 20 different predictions, and here I just point out to 4 of them, which might be related, a bit more related to AI and interesting for this conversation. The first one, potentially, in the next 20 years, we will be living on the planet of the bots. Basically, with the current speed of progress, we will have more and more of application of AI in different forms of robots around our lives. In many years ago, we had the Industrial Revolution, which basically automated a lot of our physical work in the factory and manufacturing. Then right now, we are dealing with the 4th Industrial Revolution, which is basically automating and leveraging AI and bots in the digital world. So we are talking about the robotic process automation, etc. Lots of those are automating our digital world activities. But in the next 20 years, we will bring the same thing back, combine these 2 revolutions, and have the actual robots, intelligent robots in our physical world. It will probably impact a lot our job market. However, there is a lot of discussions being said, well, AI will eliminate some jobs, but it will create some other jobs. But still, we should take it seriously and I think about definitely we need to reskill our workforce and how can we prepare ourselves to be ready for that sort of future. The other thing is potentially we can expect to have an AI winning a Oscar award, given right now we have a lot of improvements in using AI to generate contents. So for example, you can look at the GPT-3 algorithm that becoming more and more famous. So it is helping to just, learn all of the contents from whatever resources we have available on the internet, and then we just give it a few sentences or a topic, and then it starts creating the contents for us. It can become more and more powerful in that area. And however, creativity is a challenging area for AI to compete with humans. but we should consider that the advantage that the AI has is being able to consume a lot of data and analyze. So for example, an AI can better analyze and understand what are those topics and interesting areas that will trigger and make the interest in audience. So potentially could compete with humans in creating more interesting and attractive content. Technology will be a social divider. We already know this is happening right now, but it is scaling up a lot. We will have more and more of application of this sort of digital gadgets, which are being driven and planned and controlled by AI. So those people who are not very familiar or they don't have these digital gadgets at their hand, they will get more and more excluded from a lot of these services that are being provided to them. Even we potentially have more and more advancement in providing healthcare to people, and if there is a gap, it will exaggerate the current gap and will cause a lot of issues. And on the health topic that I just briefly mentioned, we can expect we become more proactive and preventive rather than the current healthcare industry, which is waiting to something happen and just try to be reactive and fix a disease. So we will have potentially more and more sensors in our bodies, constantly monitoring all of the measurements and the situation and behavior and trying to help to prevent any sort of diseases. If you are interested, you can find out about the other predictions in that link. But I have to move on, given the limited time. Quickly, I will touch on a few examples of actual application of AI. Currently, AI is all around us in our lives. Also, it is impacting and exists on lots of, or I can say, all of different industries around us. So without taking too much on this, let me go to actual examples, because that can be a bit more interesting. So I will give a few, maybe 3 or 4 examples of current application of AI here at KPMG. The first one is compliant customer communications. With the current very competitive market, businesses are getting more and more pressed under this competition pressure, and then they need to find better ways to differentiate themselves from others. And one of the areas that is becoming more and more important, because competition and the cost of quality are becoming very narrow margin, is competition on the area of the customer communications and customer satisfaction, and also making sure all of those communications are compliant with the existing guidelines. In this example, the client have been doing lots of manual work that usually goes through manual reviewing of the documents, which is related to the communication between the customers and the business on the communications that they have about the services, more specifically on the loans. And these reviews are in order to make sure if these communications are following the policies and the expected quality. So KPMG provided an automated service which using AI and natural language processing to automatically review all of the documents, making sure all of them are compliant. In addition, it will help them to analyze and see what are the potential challenges in the previous communications and how those can be used in order to improve the upcoming future communications. In general, it helped a lot to improve the productivity, reduce the cost of those manual processes. Also, it will help them to become future-proof based on analyzing and planning based on the lessons learned from the past communications. Another example, chatbots are quite familiar for everyone, but COVID-19 caused a lot of impact and increased demand on this sort of intelligent agents. So chatbots can be, at a very, very simple form, they are mostly similar to QA tools. However, in a bit more advanced situation, your chatbot should be smart enough to identify the intents of a customer and exactly try to adjust the response to that specific intent, not necessarily just look for keywords and treat it as a QA case. So our clients started having a lot of incoming volume of inquiries from their customers because everybody is going back to lockdowns and they start having communications through digital channels. And also they have a lot of uncertainty about, okay, what are the policy changes in this new situation? What are the limits and so on? What is happening to their expected services? So KPMG helped to set up these intelligent chatbots for the clients. It helped to deliver a lot more reliable and consistent service to the clients because situations are changing very rapidly. And if you want to service all of these through actual humans, then there should be a huge process behind the scenes in order to make sure all of the operators are aware of these questions and the changes to the policies. However, using these chatbots not only increase that capacity to service, but also it will increase that reliability to quickly change those policies and the situation without being worried about the human error side. Cognitive vouching is another example. In a lot of cases, when you are reviewing the processes within the company, you might need to extract specific data from complex documents. For example, let's say the dates, the time, the values like invoices and so. You need to extract all of those and then match them to other existing data sources to make sure, for example, an order, the purchase order matches the invoice and then it matches the actual delivered and the payments. So KPMG, again, leverage machine learning, optical character recognition, and natural language processing in order to combine all of these, scanning the documents, extracting all of the important and relevant information, and then match them to the other sources. So it significantly reduced the cost and increased the capacity of the actual human operators in order to focus on higher level value activities. And also it enabled to scale up rather than doing this sort of reviews and checks in small samples. We can do it in the larger samples. Quite different example, just to change the scene. KPMG worked with Taronga Zoo and AWS in order to create a computer vision based solution to monitor penguins in Taronga Zoo and help with the animal welfare. Basically, we developed a monitoring system which constantly check and track the penguins inside the zoo and making sure their activities, their behavior, and their location is as it's supposed to be. So if, for example, a penguin is a lot less active in a day, or if they are in a position that they are not supposed to be, or if, for example, they are having a kind of aggressive behavior against each other, and so these will be automatically detected and help them. A bit more advanced versions of this, it could even detect the breathing rhythm of the animals and identify if it is the normal case or not. A modified version of this is being developed in the US to be used for social distancing monitoring in the public spaces and so on. So having a look at the current challenges, one of the key things is if we want to be successful with our AI solutions, we need to make sure it is being accepted and used by its stakeholders. And that is a critical thing about any sort of new technology. KPMG did extensive research together with the University of Queensland last year, and this year we expanded that to a few more countries to assess the public attitude towards trusting AI. Currently, we see majority of people either tolerate or, well, accept AI, but we have very few people to actually approve it or embrace it. So if we want our AI technologies to be successful, it's not only making a great AI solution, we need to make sure we can shift people towards right, and we have more people who actually want to embrace it, actually not only use it, but also trying to encourage others to use it. And through this research, this is just a path analysis and a path model. So we found, of course, there is a big impact from trusting the AI system to making sure people accept it. And we see currently the level of trust in Australia, trust in AI systems is pretty low. So about half of the people, they are not willing to share their information with AI systems. Or about 2 in 5 people, they would not trust or they would not rely on AI output. And this is directly impacting the AI acceptance. So what is driving that trust? If we dig further, of course, there are many different impacts and drivers, but here are 4 of the key drivers. The current safeguards is at the topmost with the most impact. So if people feel the current safeguards and regulations are good enough to control AI systems, then they are more willing to trust it and, of course, accept it. AI uncertainty. The more people feel that the future of AI is uncertain and they are not aware that what will happen in the future, what will be the impact on the social impacts of AI, then the less they will trust it. Job impact, of course, if people feel AI is going to put people out of their jobs, they will trust it less. And familiarity with AI, it was very interesting to say we have a very low level of familiarity of people, both subjective and objective awareness of AI in the public. And the more people are familiar with AI, the more they will trust it. So looking at the time, I will just rush it. If I want to highlight a few of those important key challenges areas, the first one, I will say diversity in AI is very important. Gender diversity in AI is just an example or a key area, but diversity in general is important because the more diverse people are involved in design and development of AI, the more reliable that output will be. In that research report that is published, we discuss it in a lot more detail. The other thing is currently we have people usually going into the 2 extremes. Some people are saying, no, we shouldn't trust AI, we shouldn't use AI at all, let's just rely on the human processes only. The other extreme are those who say, okay, yeah, definitely AI is good, everything should be automated. But the thing is, we should consider AI alone cannot be as successful as it should be, especially in the sensitive and high-risk areas. So rather than just artificial intelligence, we should look more into augmented intelligence and use AI in places that it makes sense, but have that human supervision or human final confirmation there. Current regulations, as we discussed, are not ready, and in a lot of areas we have unanswered questions about AI because it is changing a lot of things. So definitely we need more strong and updated regulations, and also a lot of ethical considerations about AI. Cyber attacks, AI is bringing a lot of new vulnerabilities, which is not being still considered serious enough. And that is an area that we should be more cautious about it, and we should increase the awareness of people. Final word in general, I think, of course, AI, machine learning, data science, fantastic field to launch your career in. No surprise to hear it from somebody like myself, but it's not just self-promoting. I believe it is the future, and you can already see the impacts around us. A very important thing is to consider, if you are in this area, if you are planning your career here, never forget that you should always closely work with the domain expert and the industry. We see still a lot of people coming into the industry with the idea of, yeah, just the technical side, just the algorithm, machine learning, that can solve everything. And the result of that is building solutions and models which is not really solving the actual business problems. Be bold on your innovative ideas. Nothing in this area, nothing is a stupid idea. Try to leverage all of the new technologies and tools and combine it with your own ideas, and try to be innovative, because everything is changing very rapidly in this area. Sorry, I went a bit over time, but I'll available to any questions.
Thank you, Ali, for that wonderful overview of the future of AI and relevant considerations. Just a reminder to everyone, just please post your questions in the Q&A function and upvote the questions you want to see answered. I'll pass over to Aidan to host the Q&A.
No worries. Thanks for that, Liz. Just a short introduction. I'm Aidan Khalil. I'm the Industry Partnerships Manager at Monash DeepNeuron, and I will take over emceeing for the rest of the night. So I just wanted to extend a big thanks to Dr. Ali. I think personally, the advice to university students at the end was very valuable to me. So let's just get straight into the questions now. So the first question here mentions, so you mentioned that technology will be a social divider. So what actions do you think we could take to prevent such a divide?
Yeah, so partially we expect the governments to think ahead of time and try to consider regulations and considerations which look into, inclusive view to the citizens, and making sure all of the services that are provided is considering that part of the society, which maybe even at the moment doesn't have a digital identity. And part of the role is over to the businesses and companies to make sure whenever they are creating new solutions, they don't forget about that part of the public, which might not have all of these services available. It's not easy, like always, like many of the challenges, but the main thing is not forgetting about them. Well, yeah, as long as you have considered that in the designs, that will help.
Yeah, definitely. Great answer. On to the next question then. So out of the 20 predictions you mentioned, which would you be most interested in seeing come to reality? And to follow on from that, which would you most like to drive?
Well, all of them are very interesting things, and these are predictions for next 20 years. So it's still a bit hard to say, given my own area of expertise. Of course, I'm very interested in those 4 that I selected. And if you say amongst those, I like the healthcare, using AI actually to collect and constantly monitor data from our health and trying to prevent diseases rather than waiting for symptoms to appear. Having said that, it will be also creepy. We have already seen a lot of this sort of science fiction movies that, you know, when this data is available, then how are you sure that you can protect it safely? And how are you sure that it will not go wrong and suddenly start, you know, if it is making mistakes, it start messing up things in your health?
Yeah, true. Definitely important things to consider with AI. So another question asked by Yusuke. So what skills do you think will be most important to adapting the changes you predicted?
So again, if you consider that whole 20 predictions, that is a very broad thing. But the changes that we were discussing specifically about AI and data, I will say the data literacy is the very first step. And when I say data literacy, it doesn't mean like data analysis and data manipulation things. It's a matter of having that broad understanding of how data can be collected and impact our lives in many different ways. That is the beginning step. And then from there is how you can apply that in your area of activity. So not everybody is necessarily a data person, but let's say, for example, you are a tax agent, a tax specialist. So having that initial understanding of data, then you can project it into your own specialty and say, okay, so what are the data that can impact your area of activity, and how it can be used in order to improve your area of work. Then based on that understanding, you can plan to learn further on those areas.
I see. That makes sense. So we might want to wrap it up with one more question, just looking at the time. So this question was asked by Mubashir. So what do you think is the most important thing AI companies should focus on in order to improve the general public trust in AI?
One, well, already we discussed about quite a few of them. I think it's important to consider beyond the technical side. We say that trust is being built on 3 key pillars. One is ability, which a lot of those technical capabilities fall under ability. The other 2 are integrity and humanity. So I think currently the other 2 are being missed. We don't want to overemphasize to scare people and like say, oh no, AI is not good and it is scary. But the other 2, humanity and integrity, are, for example, the ethical sides, the fairness, the making sure there is no bias in the system. These are areas that if companies can show they care about it and they are considering it, it will increase the trust. Currently in those researches, we see one of the trends that we can see is majority of people think businesses are using AI only for their own benefits. So they don't consider the benefits for the customers. If they see this is considered, then hopefully it will increase that trust a lot more.
Thanks for that. I think that probably wraps it up. I think we'll have to move on to our next presenter, but again, Dr. Akbari, thank you so much for volunteering your time. I think I can speak for all of us here that we've learned a lot from the presentation.
Pleasure. Thank you very much.
No worries. Thank you so much. So on to our next presenter. Our next speaker is Dr. Adam Makarucha. I believe he is a data scientist with IBM Garage, where he co-creates data science and ML solutions with customers. He completed his postdoctorate at IBM Research in 2018. He worked on deep learning applications in the financial services industry. So Adam has more than 10 years experience in using high performance computing to solve data science problems with a focus on GPU acceleration. His current interest is on how generative AI can be used by designers and artists to enhance and accelerate how they produce content. So Adam, Dr. Adam, if you can share your screen,
sure thing.
By the way. Thank you so much.
No worries. Thank you for that introduction, Aidan, and thanks to the DeepNeuron team for the invitation to speak today. So yeah, I'm Dr. Adam Makarucha. I am from IBM, and I'm going to be talking about a project where we're using AI and particularly generative AI to bring history back to life. Now, this is, I think I divide projects up into, in the industry into three sort of use cases. One is where AI is used to get an output, a report of some sort. This is one of those cases where we're getting some physical or object out, whether it's a report, maybe you did some data mining, get customer segmentation, that might be an example. In this one, our output is images and video. The other use case, which we see in the industry mostly, and I won't be talking about today, is where we're developing a specific API for a customer and they get an API outcome. And the final I think about is where we deliver a platform for a customer that are actually generating their own AI models and generating their own IP. And you can think of the companies that might do this as, you know, the large industry companies like the big banks, maybe the large telcos, as an example. And that's how I divide sort of the use cases we see across the industry. And this is just one of those use cases. And if you have me back at any point, I can talk about some of the others. But this first project was a project we did in collaboration with Qantas. So Qantas, you may know, celebrated their 100 years back in 2020. It's a tough year for Qantas in 2020 though. They had most of their planes grounded. They had 70 or 80% of their staff stood down. And it wasn't a great year for them to have to celebrate their centenary, a massive milestone for any company, but one for an airline is actually huge. And they didn't really know how to celebrate it. This was happening in mid-November, and they have a massive back catalogue of archival images from their history. And that history is really important for not only Qantas, but for Australia. If you think about what they have done for the country, allowed us to move around the country. They have been involved in war efforts, in World War II in particular. And they're a national icon. And they really didn't have any way to celebrate that. So we partnered with them and we said, well, we can actually take these images you have and give them new life, so that people can see that history of Qantas in color and remastered for the first time. And we can do it with AI. And so this is an example of a Catalina, one of the water planes they have, that was flown in just after the war, World War II. And we can bring it to life using AI. We took on this project, and we took it on only a few weeks before their centenary celebration in late October. They provided us with 20 images and a 90-second video to colorize. Now, if you were to do this and do colorization only, it might take anywhere between 5 and 20 weeks, depending on the complexity of the images. So how many people, how many objects are in the image, the complexity of the video as well, how many scenes change, how consistent each scene is, and the quality. And the video they gave us was about 95 years old. So it was quite challenging to remaster and colorize. But with AI, we could do all of the inference on the video and the images in 6 hours. And really only took us a week to retrain the models we had to identify the correct colors of, say, the Qantas planes and the uniforms of the staff. And that include not only the colorization, but a whole remastering process that I'll talk through. So the technique we applied, and this is generative AI, and this is AI where we're generating something new. You're probably familiar with it when you look at some of the work that OpenAI has done, in particular around text generation with GPT-3, where you've got a natural language model that's generating words and text. And they've recently combined that model with an image generation model, and it's called DALL-E. And they're taking text as an input, encoding it using GPT-3, and then from that encoding, generating new images. And this is an example. They take a text prompt like this one, where you've got a baby daikon radish and a tutu walking a dog, and it generates a whole range of images that represent that text prompt. So we're applying the same types of models. You might have heard them in more nefarious use cases for things like deep fakes. But in our case, I feel like we're using them for the purpose that they were built for. And that's for colorization, remastering, and improving images in general. So if we take the example of colorizing an image, we used a generative adversarial network to do this. And this is the type of network. So in it, we have a generator and we have a discriminator. So they're the two models. Now, if you think about the generator, let's call it a forger, and the discriminator we can call a judge. And the way you train this model is you take images that have color and images that you've removed the color from. So now they're black and white. And you pass in the images that have color, the real images, into the model, as well as the black and white images. And what you're getting is the forger to add color to the image. And it's trying to trick the judge into thinking that this is a real image, that it's not a forged image. Now, the judge is pretty good at identifying early on that this is actually a fake image. And it's also seeing real images, and it can identify them as real. And it learns, it's just a binary classification. Is this a real image? Is this a fake image? Over time, we're also improving the forger. The forger is getting a lot better at adding color, but the judge is also getting better at identifying true, real or fake images. But the forger gets so good at a certain point that the judge can't determine what's real and what's fake. And it starts to think it's real. And that's when we can take this model and apply it to images, black and white images that have never had color. And it'll apply the real color or a color it can perceive in the image. So it's learned the context of things like a person is a person, the ground and the grass is grass. And so it starts to apply the right color into these images. Now, the other type of network that we applied and used, it was another deep neural network. It's called an autoencoder. And this is for the task of, in this case, is upscaling images. So it's called super resolution. And what we do is we take a, say, low resolution image, pass it into an autoencoder that effectively reduces the number of dimensions that is representative of that image. And as it's doing this, it's encoding all of the context into this latent space vector. Things like, what is a person? What is the ball? What is the grass? What are shoes? What are hands? What's hair? And then we can take a mirror image of that first part of the network and decode this back out into a full image. But we can actually add a new layer so we can get to a higher resolution. And we produce what is at the end a very sharp image, a higher resolution image. And the way we train this model is we take high resolution images, we downscale them, and we pass them into the network. And so then when we start with a low resolution image, we can scale it up. And this is very important in the task of remastering images, because occasionally what happens is an image has been digitized at some point in the last 2 decades. And it may have been digitized at a very low resolution or a resolution that's not ideal. And we don't have a copy of the original. So we have to use that low resolution image as a starting point. So we may need to scale it up to get to the quality that we need to either work with it in a print fashion or wherever it may be projected. And I'll show you a couple of examples of those as we go on. So these are the two main architectures we used. We used slight variants on these for the different tasks. Now we had to train these models, and in particular for the colorization, it's really important to train the model on color from the time and period, which is difficult. If we're colorizing things and adding color to black and white images, where do we get color from? Well, we were lucky. Qantas had just, in the previous year, created a new safety video that they show on flights that was basically a look back at their history. And they had accurately represented all of that history as well as they could. They went to the right locations, so they had the right color ground, the right color cars. They replicated all the clothing, all of the attire that was used, and the colors that were on the planes of that period. And so we're able to take those frames from this safety video and use that to train our model and to fine tune the model. And we need to do it at high scale. The couple of purposes of the images, we're going to be at high resolution. And so we have to do this at the highest resolution we can. We use one of our power systems. I'm very lucky at IBM. I have access to some significant GPU compute. We use NVIDIA V100 GPUs attached to our power systems. And one of the benefits of this machine is that it can actually run part of the model on system memory without taking a time penalty. So we could train models that exceeded GPU memory and do inference where we would exceed GPU memory. At one point, I was doing inference on a 4K image, and that image and the model in memory took up all 4 GPUs. So it was they were 32 gig cards, so 128 gig of GPU memory, plus the ½ terabyte that was on the system, just to run this through the model to get it to output at that highest resolution we possibly could. And I was fortunate that I had this tech to be able to do that. So the remastering process, well, we looked at a number of approaches. First of all, we take an image like this that was relatively low resolution. This was one that Qantas had sourced from their passengers. They had a call out and said, have you flown on Qantas? Do you have any black and white photos you'd like remastered? And one was sent in. This image in kilobytes, in terms of just size on disk, was only 31 kilobytes, and it was, I think, 768 by like 300 pixels wide. It was tiny. And so the first thing we did was we upscaled it, and we used the super resolution model to do that. And we did it about 3 times. We found that was enough that we can introduce artifacts, and for the rest of the downstream tasks of remastering, it didn't affect those models. Next was to take old archival images that had been digitized and denoise them. You can see a lot of scratches, a lot of noise in this image. That's because this one was taken about 90 years ago. And so it sat in an archive as a print for probably 70 of those years, up against a manila folder. Every time somebody opens and closes the filing cabinet, it gets scratched and damaged. And over 70 years, it deteriorates. So what we want to do is to remove all of that noise. And that's what we can do. And you can see the clarity that comes back out when we do that. And we've got a model, it's another autoencoder that's doing that noise removal. The next is we want to take out those scratches. And so we actually have a generative adversarial network that actually sort of hallucinates the pixels that are in that scratch and removes them. And so you can remove many of the scratches in these images. And we had some really good quality images that weren't really scratched, but then we had some really old ones that had quite a lot of damage. And so we applied it to the right type of images, the ones that were really damaged. And so then we take all of these things together and we add color. And so we colorize. And that's another GAN model that we apply to the colorization. And so the model has learned the ground in this scene is sandy, the horse is brown, the trees are green, and the walls in this building are sort of grey wood. This is probably my favorite shot of all the ones we worked on. It's a plane flying over Brisbane city. And from this image, it looks, kind of interesting, but you don't really get anything from the background. It looks kind of flat. But once you've applied all of that color, all of the denoising, I think it really brings out just the brightness and the color in the Brisbane city. You can see actually the river a little bit and the sharpness of the plane. This one was a cool one. It was a flight where Qantas flew Charlie Chaplin, who's on the left there, pilots the other man in the photo, and then it's his wife on the right of the pilot and his Charlie Chaplin's mother on the far right, mother-in-law, sorry, on the far right. And this was a tiny little plane where they actually only had a pilot. They didn't have any flight attendants on the plane. And what I really like about this image is the fact that we could bring out the color of the dresses and the clothing at that time. And our models have learnt that because of the images we provided them when doing that model training. Now, we had to get it right, and that was one of the key important things. Planes are very, and anybody who is an airplane enthusiast would know that planes are very specific colors. And in particular, one of the first planes that was flown by Qantas is this Avro. And this plane is a particular green. If we had got this wrong, we would have been in trouble. And we were fortunate to walk with a historian that the Qantas has on staff. And so we worked closely with him to make sure we got the right color. And so we went through a few iterations in colorizing, and the Avro is the plane in the background of these two images here. And you know, we did a really good job of making sure we got to the right color. We trained on as much data as we could, and we could tune some parameters in the model when we were doing inference to get that color right. And so the centenary came around, and Qantas posted out these images on their social channels. They got a lot of interaction, a lot of engagement, and that was very exciting for Qantas in that they were able to show their history in a new light, in a new life, basically, than they hadn't been able to imagine they would have been, especially in this tough year. And even this image here was actually projected onto the harbour bridge. And that was one of the reasons we had to get this, the resolution as high as we can. If you're projecting at that scale, you can imagine you need reasonably high resolution image. I think this was one of the most exciting things I saw. So Philippa Coates here has commented, and this is her grandmother in the middle of the shot, Ivy McLean, who was the first woman passenger. And what makes me excited about it is it's probably the first time Philippa Coates has actually seen the color of the plane, recognized seen what her grandmother would have seen. That would have been an absolutely exciting journey for this young woman who's 22 at the time and getting on a plane, a two-seater plane in 1921 when Qantas has only been around for a year. Pretty amazing, I think. Now, we've done some more of this work. You can see it. We've got a couple of blogs up. So if you want to learn more about it, and there's some more details on these blogs, so you can go and have a read if you're interested. One of the other pieces of work we did was with News Corp, where we colorized some Anzac footage photos. So this was a picture from World War II, and it was published on the front of the Sunday Telegraph. That was on the day after Anzac Day, when many of us were in lockdown. And again, it was an opportunity to bring something to life where we couldn't necessarily go out and commemorate in the way we normally. As most of you know, a lot of good work never ever happens by one person. There's a team, and I work with two great data scientists, in Ben and Narantika. And we also stood on the shoulders of giants. There was a lot of great research that we used and developed on top of, and so some of that work is just referenced here. So thank you. I'll take any questions.
No worries. Well, thank you so much, Dr. Makarucha. It was really great to hear from you. I thought that the Qantas project was a wonderful and really unique use of our application of AI. And I love the demos as well. So I also enjoyed the explanation of how the model works and learns. It's definitely something for our training team to take on board and from a teaching sense. But anyway, let's move on to some questions. I'll read out some audience questions right now. So I'm sure a lot of people here are keen to get started in this area. So what sort of beginner projects can university students undertake to learn more about encoder-decoder models and colorization models?
Yeah, I think one of the best ways to get started, and one of the things, the way we got started, was actually to find a project. Ben, the guy I worked with on this, he actually is on a Facebook group for his old town. He's from Newcastle in the UK, and people were posting black and white photos. And he'd seen some people colorize these just using AI, and he got really interested in it. So he started going, all right, maybe I can do it. Maybe I can develop some things. And from there, that's where it sort of snowballed. We started playing around with some ideas, generating some colorized images, upscaling some of them. And that's where we just got lucky and talked about it in a couple of meetings and got these outcomes. So I think the answer is just to find a real problem that you're interested in, real data. I think that's the hardest, is to find a real use case. You know, find something you're interested in. It doesn't have to be colorization. Maybe you're interested in style transfer. Can I create, you know, do the typical style transfer of take an image and turn it into a Picasso. and how can you get the data, can you train the model? You'll learn so much in that process of just having a real problem.
Definitely some really good advice. I guess following on from that, for some of the more technical members in the audience, at a lower level, which sort of networks are used for the colorization models?
Yeah, so the underlying architecture of the colorization model we used was a UNet architecture, which is fairly common for GAN models. And that seemed to perform the best. We make some tweaks to that underlying model. So one of the things that a lot of people do with GAN models is the encoder is quite a deep technical network, UNet, for example, but the decoder model is quite shallow, and it's just because it's just doing binary classification on an image. And what we did is we actually took the step of going, no, the binary model needs to be more complex, because what we were finding is that when sorry, I was saying decoder, what I meant is the discriminator model. The discriminator model in the GAN, in this case, was not doing a good job at identifying where things were not colored. So we'd get this thing called, what we called as a zombie hand, where we'd have a hand that just was totally uncolored. And this really just, it never got picked up. The discriminator never saw it. So we thought, all right, let's make a more complex discriminator model. So we went with an efficient net discriminator model, and that seemed to perform a lot better, a much more deep neural network for that task. The next step, I think, is we're going to look at, can we train a neural network that's more around image segmentation and is actually identifying parts of a person and whether they are colored or not. And I've seen some work around that where they've applied object detection to do something similar. So we might be investigating that as the next step.
Really interesting stuff. Maybe we could look to incorporate a lot of that stuff in the projects we're doing. Just a reminder to people to keep sending questions into the Zoom. Just a couple more questions. So when coloring an image, how do you accurately re-represent the image? So how do you know you got the right Qantas colors?
Yeah, so that was where working with the historian was really, really important. So the historian has actually seen the planes, for example, and so that Avro plane, which is that green, he's actually seen them, so he knows exactly what color they are. Where we don't have that luxury of having a historian, it can become quite difficult to identify and make sure we get the real color. So we were fortunate that they had a historian on board. We've worked in the past, we did another project where we colorized some AFL footage, and it was of two teams that played in the UK in the middle of World War I. And nobody had any representation of the color of the Guernseys. And so we had no idea which color was which. We were able to locate a news snippet about this game from that time, and it actually labeled the color of the Guernseys as the blue team and the red team. And because we were able to get that information, we were at least able to get a start on the right color. And so we can change parameters. We can do some segmentation of the players in that case to then give basically the model a hint to say, apply this color to this part of the image, and then it'll apply the correct color.
I see. Okay, definitely makes sense. So I guess another question, this one asked by Scott. What are you excited for with the future of generative AI? And is there anything that you are particularly scared about?
So, I mean, I'll start with the scared stuff, so I end up on the good stuff. I'm a little bit concerned about going forward where, a scam call is no longer that robotic voice that calls and says, hey, you have a tax bill on the ATO, you better pay it. And it's just clearly a robot and it's clearly not a real person. I'm scared that when generative AI gets to the point that it can, and it probably already is there, but the cost of generating voices gets lower to the point that it sounds like a real human voice on the end of the line. And that's when I think people will get, we're going to have to really educate people on how to watch out for that type of scam behavior. So I'm concerned about that use of generative AI. What I'm excited about is what it frees up designers to do. Designers probably don't necessarily want to spend all day drawing. They want tools that accelerate their creative behavior, and that's what generative AI allows them to potentially do. And you can see Adobe is already integrating a lot of this technology into their products to allow you to take maybe the OpenAI is a great example. Let's type up a text prompt of what I want to see, a cartoon, it might generate it, and then I as a designer can go in and fine tune it from there. I've now got more time to generate more interesting artwork because I've been able to generate so much of the sort of foundational stuff already.
Yeah, definitely. AI is a bit of a double-edged sword. So it's definitely some scary stuff. I think even with videos nowadays, I think you're on the right track in terms of educating people for the capabilities of AI in the future. I guess maybe we'll just get one more question asked by Timothy. So Timothy says, really impressive work, Adam. You did a great job presenting the process as well. It really shows that the possibilities with AI are immense. If you could briefly explain some of the other greatest projects you've worked on, professionally or academically, I think I and the other listeners would really enjoy hearing it.
Yeah, sure. So another project I worked on, image related as well, was with an environmental protection agency. And so they had, this was in South Australia, they were looking at how they could prevent shore erosion. And one of the methods for preventing shore erosion is making the seafloor really stable. And we have a natural barrier, which is seagrass, to do that prevention. And they were finding that seagrass was dying across the South Australian coastline. And so they were getting out in boats with GoPros and actually recording the seafloor and a grid to get an idea of the health of the seagrass. And so I had 500 hours of seagrass footage and nobody looked at it for 5 years. And they really needed to know, we were putting in prevention measures, are they actually working? So we built an image segmentation model that could identify seagrass versus seafloor, and the density of the seagrass in an image. If it's 100% seagrass, it's pretty healthy. If it's 50%, it's not so healthy. It's 10%, it's nearly dead. It's gone. And so we built this image segmentation model that could take a video in, process the video, and identify where the seagrass was and what density it was in those frames. And they now have a tool which they can upload this image video to and then focus on the areas that are really deteriorating to prevent the seagrass from dying off, to protect the shoreline from further erosion. That's one. Another really interesting one I worked on was for this blockchain startup. They were interested in they provide an application that basically helped people who were in cryptocurrency investing invest in the right cryptocurrency. And as many people would know, cryptocurrency is really volatile and also influenced by social media commentary. Say Elon Musk mentions a particular cryptocurrency, the price skyrockets. So we built a classifier that used transformer models to classify the sentiment of tweets, rank that based on how many followers, how many retweets, and then other social channels as well, like Reddit and Telegram, for example. Combined all those together to give an overall assessment of whether the market was positive or negative based on those social interactions. And it was just really interesting because you couldn't apply a standard off-the-shelf sentiment model because there's a misspelled word that's used often in cryptocurrency. It's HODL, which basically means to hold your cryptocurrency. But every model would just classify that as a misspelled word and it would become an unknown token and have no influence on the sentiment, where it was really important for determining the sentiment. So one of the reasons we trained a specific model for that work.
Really interesting stuff. I think those are really inspiring projects for a lot of us here. I think that wraps us up.
Yeah, great. Thanks.
No worries. Thanks again for volunteering your time. It was great to hear from you, and I really loved your explanations and insights like a lot of us here. So I think, yeah, best of luck with all your future AI projects. Thank you again.
Thank you.
All right. I'll just go ahead and introduce our final speaker. we are really glad to hear from Mr. Andrew Underwood. He leads the Dell Technologies High Performance Computing and Artificial Intelligence Systems in Asia Pacific. He works hand in hand with industrial, academic, and government clients to build the computational foundations critical to their scientific advancement and global economic competitiveness. So, Andrew, if you're ready, please take it away.
Perfect. Thanks very much for the opportunity to come and chat to everybody today. I'm sharing my screen, so hopefully it comes through in just a moment. But you know, before while I wait for that to come through, you know, kind of the approach that I wanted to take today was to really talk about how some of the use cases that we're seeing for artificial intelligence, but importantly, take everybody through the kind of the best practice approach that's taking place across industry. We're seeing that artificial intelligence, or this colloquial term of AI, you know, powered by machine learning, deep learning, and a number of different techniques in data science, is really pushing us to be at, you know, the precipice of the fourth industrial revolution. And, you know, this is where organizations are really looking to lead by leveraging these techniques in order to connect their factories, their products with sensors, in order to transform from an industrial mindset into a digital mindset, really underpinned by artificial intelligence. You know, and importantly, you know, we're kind of seeing that, you know, we're 1600 years after the ancient Greek scientist Heron of Alexandria, you know, mentioned this rudimentary steam engine. You know, an invention that went on to create the first industrial revolution, which really allowed for the production, well, for production itself to be mechanized and forging that modern age through industrial culture. You know, we really saw that that first industrial culture led to sequential industrial revolutions, which have really driven us to the modern age that we live in now. But, you know, 250 years after the steam engine helped to spawn the industrial world, advances in computational technology, ultimately along with the merging of sensors and digital technologies in particular, are really changing the fundamentals of the world that we live in. And the fourth industrial revolution goes well beyond manufacturing, with intersections of technologies and cultural enabled cyber connected systems that extend well beyond the factory floor. And at Dell Technologies, we really believe that it will transform the way that we live and relate to one another. And it's going to be able to create new industries and new economic growth in what we refer to as Industry 4.0. And this is what I really wanted to focus on today. You know, a lot of these companies that you see on the screen now are common companies that are part of our everyday life. And, you know, digital transformation in particular, underpinned by these data science techniques, has created a rapidly changing business environment. You know, 52% of the Fortune 500 firms around the world since the year 2000 are gone. Digitization and these data science techniques that underpin it through allowing or enabling automation are really disrupting the value chains and compelling companies themselves to rethink nearly everything they do when it comes to products they develop and services that they deliver to their customers. Many of these companies have come out through innovating against competitors that when I was in college were, you know, leading companies like Blockbuster Video. I think while I was studying, I was actually working at a Blockbuster Video, and you know, these are companies that didn't adapt. They went bankrupt in 2010. And it wasn't necessarily because they didn't transform, but their competitor, their biggest competitor, Netflix, really pioneered video streaming. And a lot of people don't realize, but Netflix's entire platform is built on the foundations of machine learning being able to understand and relate to what the viewer would like to potentially watch based on people with similar profiles, based on the time that you spend on your phone reading a description for a movie, or even based on how long you spent just reading watching the credits and reading through the credits at the end of a film. And it personalizes your experience using the data that you feed in through your viewing experience and through your interactions with their applications, be it on your TV, smartphone, or on your PC or laptop. And these companies taking a more digital transformative approach underpinned by data science are really the ones that are pioneering the fourth industrial revolution. And while many of these companies are customers of Dell Technologies, they build their infrastructure using Dell Technologies compute platforms. I wanted to share today some real stories of digital transformation. And that's because, largely I find that, AI is going to intersect with everything that we do in life, especially as consumers. When we interact at home with things like Siri or Google Now, etc., we're obviously interacting with natural language processing platforms. But there are some quite compelling and really interesting applications of AI that are completely changing the world that we live in. And they're addressing some of the world's greatest challenges, particularly healthcare, agriculture, and global warming. So today I wanted to take you through a little bit of a journey with some of these real transformation stories. And I thought I wanted to start with one of our customers, Aerofarms. But before I do, we all face, everybody on this call today, everybody in the world faces an ever-growing global population crisis. We're effectively trying to feed an ever-growing population while trying to conserve the valuable natural resources that will feed us and help us to sustain our lifestyle. And unfortunately, as you can see from some of this mapping data, you can see just the impacts of things like harmful agricultural chemicals, the impact of river runoffs, and are equating to dead zones with feeding an ever-growing population. And over the last 40 years, the Earth has lost 1/3 of our arable land just in the last 40 years. And that is something that we have to address. But additionally, by United Nations estimates, we actually need to produce 50% more food by 2050. Yet we've lost 30% of our farmland just in the last 40 years. So there are some major challenges that are facing us and facing all of us today in order to be able to, for humanity to survive. And this is where a Dell Technologies customer called Aerofarms comes in. This is for them where they take science digital and farming vertical. To Aerofarms, their approach has been one built on this cultural shift towards embedding AI in your company's cultural DNA. And what I mean by that is that to Aerofarms, every farmer inside Aerofarms is a data scientist, and every plant is a data point. So Aerofarms is a 24/7 vertical farming operation. They're based in North America, and what they actually do is they go around the United States and they buy derelict and abandoned buildings. Many of these buildings could be nightclubs in cities where they were once flourishing, and the population moves out, and so Aerofarms will come and they'll buy these vacated buildings that are just quite odd, even in shape and architecture, where they might be quite narrow and quite long, and nobody else wants to be able to do anything with them. But as I said in one example, a nightclub once thrived there. And they build these buildings with the intent to build commercial scale indoor farming that is disrupting the traditional growing seasons. And it's all rooted for them in their approach to data science, coupled with computational technologies and platforms, in order to help their experts to unearth this, data to drive insights and ultimately a greater yields and tastier crops. Now, at Aerofarms, as I said, they actually take an approach to AI that is built on life sciences as well. So to them, it's not just the approach of, okay, we've got farms and we want to look at automation of these farms, but they actually leverage the approach of phenomics, this the study to uncover the mystery of plants and living organisms, and they actually feed all of the data for the phenotypes of plants that they can be able to collect using IoT sensors in order to build an algorithm that's able to watch the plants grow and learn from how the plants grow. And this is actually really important because within the Aerofarms environment, where they have these large vertical farms that I'll show you in just a moment, they are able to capture the data from everything from seeds to package loading at temperature, humidity, airflow, nutrients, light, water, and food safety. All of these growing environment data points as part of the phenomics research that they do, and they're able to capture all of this data as part of the development of the plant, the growing development of the plant, and build a deep learning algorithm around that does a couple of things, which I'll get to momentarily. And the intention is to be able to study the plant using or learn from the plant's growing habitat, and then ultimately use automation to respond to the plant's growing habitat by increasing certain things like oxygen or nitrogen in the soil, or even an increase of water. And in order to actually do this, they have to use all of these IoT sensors. So you can see in this picture here what a vertical farm looks like. You can actually see what we would typically call a farmer, who's actually a data scientist at the base of one of the vertical farms. And they have all of these IoT sensors inside the chamber of the vertical farm. And inside that growing chamber, they're able to capture everything from the oxygen, water, nitrogen, whether or not there's enough airflow, etc. And it's pretty interesting because I don't know about many other people on this call today, but I myself, while I'm a technologist at heart, one of the things that I love to do on the weekend is I actually love to garden. And so in my garden, I can typically tell whether or not a plant is healthy by using just a handful of my, trained or learned opinions about growing flowers and plants in my garden. I know that if the leaves are too yellow, then typically I need a little bit more nitrogen. I know that if my leaves are black, then there might be too much water in the soil and not enough oxygen in the soil. I know that if my leaves are wilted, then I need to be able to increase the amount of moisture and water into the soil. And I typically use just those three key indicators in order to increase the production of my veggie patch or the flowers and plants that are in my garden. But what I found really interesting with Aerofarms was their use of IoT data. In fact, because they have so much IoT data, IoT sensors inside each growing chamber, this is everything from, as I said, sensors that are capturing humidity levels, oxygen levels, nitrogen levels, water amounts inside the chamber. They actually have 120,000 data points per level of the vertical farm. And as part of the complete crop production life cycle, they actually have 24 billion data points per crop harvest. And they're able to actually use all of this data to manage the phytochemistry of each plant individually. And this effectively allows them to monitor the health of the plant and then respond to the plant's phytochemistry in order to increase whatever nutrient levels or oxygen levels or water levels are required in order to increase the production of the plant. And as you can see here, through doing this and using deep learning on the application of deep learning inside the growing habitat, they're able to reduce their water usage by 95% versus a traditional open air farm in, outback Australia as an example. And they're able to increase their crop production by 390 times. Versus a traditional open air farm or open field farm. Interestingly as well, they're also completely pesticide, herbicide and fungicide free. And I wanted to dive in on this in particular. So they're, as I said, they're completely herbicide, pesticide and fungicide free. So they don't use any of the production of their plants. And the reason for this is that by using computer vision and building a convolutional neural network using a camera inside of the growing habitat, they were actually able to optimize the photosynthesis of the plant in order to respond to I guess insects in the growing habitat. And what I mean by that is that most leaves inside their growing or the vertical farm are not actually green. They only reflect the green spectrum. And in fact, certain pests and bugs can't actually see the green spectrum themselves, or can only see the green spectrum, I should say. So what Aerofarms has done using convolutional neural networks is they actually use a camera in each of the vertical farm's chambers, and through that camera they monitor for insects. And as insects and bugs come towards the chamber, these are things that they just can't keep out of the buildings for obvious reasons, unless they were using pesticides, which they refuse to use. The camera actually monitors for the bugs. And as a bug comes into the shot of the camera, there's actually a light above each of the growing chambers, which then turns from a white light into a purple light. And then that makes the plant reflect the purple spectrum. These bugs, through millions and millions of years of evolution, they can't actually see anything other than this green spectrum in many cases, which means that they actually aren't attracted to the plant, and so they don't actually eat the plant. They don't affect the plant, which means that Aerofarms can be completely herbicide, pesticide, and fungicide free, and they don't have to use these harmful chemicals in their production environment, which then means that they're able to reduce their the impact on the carbon emissions, as well as things like having to recycle these dangerous chemicals through their wastewater system as well. And this is all completely using phenomics as part of the growing life cycle, coupled with deep learning, specifically in this example, convolutional neural networks, in order to identify pests inside the environment. I mentioned earlier how I myself, in my garden and my veggie patch, I use typically 3 features that I identify visually with a plant in order to, make sure that I'm giving it enough nitrogen, reduce water or increase water. What Aerofarms found over the production of their crop was that deep learning was able to identify and 84,000 unique features, 84,000 unique features per plant per growing cycle, which means that it's able to leverage these 84,000 unique features in order to respond to the plant. And it builds that into a probability of, do we need, what's the likelihood of increasing water at this time of the day versus in 15 minutes versus in 30 minutes versus in 2 hours, as opposed to waiting for a farmer to be able to come along and water their crop. So it's quite interesting how they're able to, build all of these data points using IoT to be able to, consume less water, increase productivity, and then also not have to use these pesticides, herbicides, and fungicides, which could run off into wastewater and damage local environments as well. And as you can see here, this is an example of the growing chamber where you can see the lighting system. And so should a bug or an insect come into the chamber, any one of the numerous cameras that exist throughout each of the chambers would be able to detect it and then turn the lighting from a white light into a purple light, which then makes sure that the leaves don't reflect the green spectrum, they reflect the purple spectrum, and the bugs can't see it, and so they'll leave the chamber. In an environment like Aerofarms, what they found interesting was that really in a traditional farm, they would have, a number of roles, both farmers, agronomists, mechanics, etc., managing all of their environment. But they actually found that in a vertical farm, by using or adopting deep learning to actually as part of their core product and offering, they only really needed engineers, data scientists, farmers as the subject matter experts to help to optimize their model, and agronomists. So these 4 key roles. Culturally as well, over 50% of their staff actually come from farming backgrounds. And so over 50% of their staff, their parents or family members worked on traditional farms in rural locations. However, now they'd actually wanted to move into the inner city, study different degrees, computer science, mathematics, etc., and do a secondary degree in agriculture, and then actually apply that in order to drive a newer business model and solve some of the challenges that they actually themselves saw their parents or saw their relatives struggling with on a traditional farming environment. And so in addition to those 4 key roles on these vertical farms, there's really 4 key techniques. There's the IoT data, there's the data analytics of, being able to manually and retrospectively look through a lot of that data. Then ultimately application of machine learning and deep learning techniques through automation. And then computer engineers who are able to apply this by working out how to leverage these IoT microprocessors, building optical sensors, thermal sensors, moisture sensors into the vertical farms, and then feeding all of that data back to the data scientists who are able to build their neural networks for each of the vertical chambers. And while Aerofarms is just one example, we actually see that 2021 is really going to be a year of change around the world. While the world will still adapt to and respond to how we manage COVID-19, we also know that there are a couple of significant things that are taking place in this year. Over the last 12 months, we've actually seen the first wave of Generation Z enter the workplace. And so these are people, individuals born after 1995. And, largely research shows that people of this generation have an expectation of digital experiences inside their life. So we can actually see people who have grown up with a more digital mindset entering workforces and then helping companies to be able to shift towards a digital mindset and change their cultural DNA from an industrial focus into a digital focus. We're also seeing an increase or the adoption and rollout of 5G devices. And we expect that the 5G networks will change the data game in terms of speed and accessibility, reducing latency, increasing bandwidth networks across the world that will actually allow for these machines, be it vertical farms or autonomous vehicles, that allow for all of that to actually be connected and increasing the ability for data generation. So we can actually see that this year we're expecting to see that the data volume in the world will reach 44 trillion gigabytes or 44 zettabytes, and companies will look to be able to leverage all of this data that's coming through either consumer data or IoT generated data. Typically, last year, the vast majority of the data created in the world was actually created inside traditional data centers where server farms or web services were hosted. This year in 2021, largely because of edge computing, we're actually expecting to see that within the next 3 years, 72% of the world's data will actually be created outside of traditional data centers. So that's a dramatic shift from 98% last year to in 3 years time that 2% was created at the edge, so 98% in traditional data centers, whereas in 3 years time about 78% of the world's data will be created at the edge. And so this will continue to be, and this will be because of IoT data, sensor data, because 5G networks will allow for low latency connectivity, high bandwidth throughput for connected machines and devices. And, ultimately, in order to unlock insight and turn all of this data into autonomous responses and build these new business models, it will rely on people who know and machine learning, deep learning techniques that we, as I said, colloquially call artificial intelligence. And so these four key items are really what I see as in the year 2021 being the foundations for change. And, this is going to start I think 2021 will really be where we start to see the major shifts towards the fourth industrial revolution, driven by a digital transformation mindset culturally inside companies, connected via low latency, high bandwidth 5G networks that are able to allow us to gather and gain insight to up to 44 zettabytes of data this year alone, and then powered by artificial intelligence, being able to respond to that data, building, and this is where companies will build new business models based on these four foundational pillars. And, at Dell Technologies, our approach is that we actually don't see that the application of AI around the world is something to fear. It's certainly not like the Hollywood movies, right? In fact, we see more often than not, and in almost every engagement when we speak to customers about the adoption of artificial intelligence, is that customers are really wanting to leverage this in order to solve some of the world's biggest challenges. And this is either through, how do we innovate in agriculture? How do we innovate in healthcare? How do we innovate in science and engineering? It's not something where, companies are just saying, hey, AI sounds cool, I want to adopt it. Customers are really trying to solve their business challenges and innovate by using AI. So we actually see that our objective at Dell Technologies is to help customers to leverage our infrastructure, to put our tools into their hands in order to solve some of the world's biggest challenges that we all face today. So I think that that shift towards an industrial mindset is away from an industrial mindset towards a digital mindset is happening today. Companies that are doing that are innovating. I'm really excited to see organizations like Aerofarms being able to take such an old industry such as farming and then take a digital mindset approach to it, leveraging deep learning, convolutional neural networks to be able to understand the phenomic properties of a plant, and then be able to improve the growing life cycle of a plant and hopefully feeding more and more people around the world. So it's something that we're quite excited about, and we expect to see that across almost every industry across Australia and around the world. There will be leaders who want to be able to take this approach to be able to transform the way that the world works. That's me.
Well, thank you so much. I think I speak for everyone. That was a great presentation. I really enjoyed the wider industry perspective you offered around the AI revolution that we're all witnessing around us, with some really great examples and use cases. So I also think the mention of Gen Z, 5G, mass data, and AI resonates with a lot of us and paints a really exciting future for AI. Just moving on to a few questions now. So firstly, we have the fact you mentioned that Aerofarms are utilizing lots of IoT devices to monitor the health and environment of plants. Do you see the adoption of other IoT, cloud, and edge technologies in other industries?
Yeah, definitely. So, you know, ultimately, I think there's a real convergence between IoT, edge, and artificial intelligence across multiple industries. So, you know, I look at mining as an example. It's a huge industry in Australia, but some of the, I'll give you a perfect example. Up in far north Western Australia, there's a mining company that uses a port, and this is actually one of the dirtiest towns in terms of air pollution in our country. And that's because there's a lot of coal loading into these ships. And this is about 3,000 kilometers, I think, from Perth. So quite far in terms of, you know, your next major city. This mining company has been able to use computer vision, LiDAR data, IoT sensor data, and coming off of chute loaders that shoot coal into these, you know, huge transportation ships that are, you know, carrying, you know, 40,000 tons of coal from Western Australia to other countries. They're able to use LiDAR data, IoT data, and computer vision data to be able to perfectly align the chute loader constantly shooting the coal into the back of the ship, and make sure that as the tide comes in, it can take about 12 hours to be able to load these ships of constantly shooting coal. And so as the tide comes in and the ship sways, it'll actually continuously direct the chute loader. They're using deep learning to be able to predict when the tide will impact the ship based on weather data. They're using computer vision powered by deep learning to be able to correctly assess what's happening in real time with the chute loader into the back of the ship. And then they're actually able to use a lot of IoT sensors around the town to be able to monitor for wind, to ensure that as the coal's being pushed in, the speed of the coal coming out of the chute loader, that the wind doesn't actually impact that and blow the dirt or the waste, it's waste from the coal back into the town. And so by using edge computing, thousands of kilometers away from you know, any local serious data center, running these deep learning algorithms for convolutional neural networks as an example again, they're actually able to process all this data and in real time move the chute loader, move the ship as well as it sways with the tide, and then increase or decrease the force of the chute loader in order to reduce pollution. So, you know, I see it in the energy sector. You know, I see it in agriculture. We even see it in safety as well. We had a customer who's a university actually in Victoria. They were able to, they have a train station on their campus, and unfortunately they get a lot of, you know, just random people that will catch the train, get off on the campus, and then walk through the campus. And they were actually able to detect that somebody coming through the campus, you know, they have 340 cameras. There's 1 or 2 people that work in security, and there's no way that they're going to be watching 340 computer screens in real time. So using deep learning, they were actually able to train the algorithm to be able to detect the behavior of people based on teaching it patterns of behavior, and then obviously object detection as well, being able to teach it what an item looks like. And they were actually able to pick up within the first week of deploying this computer vision software inside their surveillance network. They were able to actually pick up a potential threat on campus where a person was pacing up and down out the front of one of their buildings on campus with a weapon, and immediately alert security that they should be able to go there. And yeah, probably not a story I should be telling university attendees, but you know, I mean, that's the reality. And it actually does turn out that the person was an ex student who was quite disgruntled. They'd been terminated from the university just less than a week beforehand, and this was able to detect that the person had actually didn't have a weapon in the side of the camera, but they had a backpack on, and they just, with their behavior of pacing back and forth across a door, is what alerted the algorithm that somebody had you know, a behavioral property that seemed quite hyper anxious.
That's some amazing use of AI. It's really extensive stuff. That's really interesting. I know a lot of us can be really inspired by projects like that. So thanks for that. So we have another question here. It was asked by Timothy. So Timothy says that your explanation of data-driven approach taken by Aerofarms was really insightful. Implementing carbon sequestration economically, or better yet, profitably is a large problem of climate change that is yet to be solved and or scaled to effective levels. I've been seriously thinking about this problem for a couple of months. Do you believe that using data-driven farming to develop the carbon farming industry can become profitable or effective in the near future? Also, do you know of any companies or organizations which are currently using the data-driven farming approach to implement carbon farming? Thank you.
Yeah, so look, it's a really good question. There's actually an Australian company. I can't remember their name, but I'll be able to look it up through my emails later, and maybe if I can send it to you and you can pass it on to I think it was Timothy that asked the question, then that would be great. But there is an Australian company that is using a data-driven approach to be able to do exactly that. They're based in Queensland. I had the honor of kind of meeting them around 2 years ago. So they came to us after reading about some work that we did around a bionic eye, helping CSIRO with a bionic eye. And they actually came to us and said, oh, we read about, you know, how your infrastructure was helping CSIRO with developing a bionic eye in Australia. We have this challenge that we're trying to work on, and we wanted to understand how deep learning can help with this. So there are companies that are doing that. They're a small startup. They've only got around 15 staff. They're not based in Brisbane. They're not based in any capital city or anything like that, which I kind of found really interesting. In order to get there, I think it took me about a 3-hour drive from the Gold Coast. And so it was really interesting to kind of be in, you know, somewhat of a rural part of Australia, and seeing a group of, young people and older farmers as well coming together in order to look at that challenge and work out how data science can actually help them there. So I can't remember the name of the company, but I'll be able to dig it up. And if you're interested, you could definitely do a bit more research on them.
Yeah, thank you so much for that question, Timothy, and that answer, Andrew. Maybe our last question for you, Andrew. So this was asked by Matrix. So what are the major challenges of the Aerofarm project? i.e., why is it not more common in the agriculture industry right now?
Yeah, look, that's a really good question. I think that one of the challenges that Aerofarms actually came across first was the cultural challenge. My partner, she's worked in agriculture for Australian agricultural companies for a number of years, and when I hear about the way that they do things, they can be a little bit what I would think of maybe a little bit archaic. older less modern concepts and approaches. So Aerofarms, really the first step was to have that cultural shift towards a digital mindset, away from an industrial mindset. They, as I said, over 50% of their staff who are farmers actually are second or third generation farmers. And so that means that, their parents or grandparents were farmers as well and worked on a traditional farm. And for them, being part of Generation Z or even Generation Y, their approach to farming was one that effectively came with more of a cultural expectation of the digital, just the digital life. So, have we thought about data here? Have we thought about data there? Have we thought about using optical sensors? Have we thought about using cameras in this growing habitat? And so they actually embraced it, right? And that's the first step. Is companies need to be able to embrace digital transformation, embrace artificial intelligence, embrace a data-driven approach in order to move away from the industrial mindset. That was the biggest challenge that a vertical farming company, Aerofarms is one example, there are a number of other vertical farmers that we work with, but that was the biggest challenge that they actually faced, was making sure that they could recruit the right staff who had a digital mindset, wanted to be able to change the industry and disrupt the industry.
Great answer. So I think that has to wrap it up. Andrew, thanks again for volunteering your time. I think we've all learned a fair deal from your presentation. For the next 5 or so minutes, we'll be holding more of a general Q&A. So I'll invite all 3 of the panelists to help answer any questions that come into the Q&A chat. So if anyone has any questions, please put it down in the Q&A chat and we'll just go from there for the next 5 minutes. I guess just while people are thinking of questions, we had a few left over from last time. So diversity is something we really value at DeepNeuron. So I'm happy for anyone to pitch in, but have any of you seen diversity of, have any of you seen the diversity of a development team impact your work in AI?
Yeah, so I would say that a lack of diversity, I've certainly seen customers who have lacked diversity in their approach effectively ruin many of their AI projects. And so from a project management perspective, the projects had been deemed a failure because it had taken them off track of deliverables and delivering the right outcome on time. They were able to salvage the project in the long run, but a lack of diversity and diverse thinking had certainly created challenges for them. One company was actually a web tech based in mainland China, and so the challenge that they had was specifically that they were trying to penetrate a market in Europe, selling or producing and then selling marketing goods for women in Europe, and their development team behind their data science team were all largely of a specific age and or a specific demographic of same age and same gender, and so the product that they were developing completely failed because they weren't actually they didn't have a diverse way of thinking about how to engage or develop the product for anybody outside of the development team ultimately.
Great answer. Adam, I realize you have your hand up. Is there something you wanted to contribute to?
Yeah. Thanks. So I'm part of a team called the IBM Garage, which is a team that goes and co-creates with our customers. And one of the things we ensure is that we have squads that go out and work with these customers, and that those squads are diverse. And since implementing these sort of diversity changes, ensuring we have diverse teams when we go out and co-create, we get better code quality, better creativity, and better outcomes. And that's not just for the customer, but generally the solution and how it affects the diverse users that actually interact with the eventual solutions. So I think it starts not only from just thinking about the diverse customer or user base, but also starts from the team that creates and having a diverse team. And I think it's been well documented over the last few years that is a really important way to be more creative and produce more usable solutions.
Yeah, just to second that, I think diversity is important in whole life cycle. We see the importance of having a diverse data in the very beginning that we do the data collection. The diversity in the design and algorithms also as well. It's very important to make sure that we design the systems in the right way. And also at the end, you know, the diversity in the way we use the AI solutions. We have seen in a lot of cases things went wrong when we use them in a, you know, very specific way, and we create bias in something that wasn't originally biased. We have seen lots of these sort of examples around the world. For example, facial recognition algorithms, which doesn't consider people with a specific, you know, hijab or other face covers or head covers. We have seen like the example that went wrong like last year in US in providing and prioritizing the health services to different people, and we see diversity that doesn't consider, you know, cultural backgrounds or the way that people behave in seeking health services. So originally the system wasn't designed to consider any of, you know, racial features or that sort of features, but it was introduced into the system through some other angles, like people with less, you know, lower financial status. They might have less visits to seek health services, and then as a result, the algorithm was expecting they are not having much real serious situation, and so on. So when we have more diversity, not only from the gender perspective, not only from the racial perspective, it's on all angles. When we consider like cognitive diversity in the end-to-end life cycle of the systems, then we can achieve a lot better results.
Yeah, great answer. I think diversity is definitely something we all need to keep in the forefront of our minds. I think we'll wrap up after this question. So the final question is, what do you think is the biggest challenges in AI and machine learning over the next few years? And what can we do as students entering roles in these fields to prepare for these challenges? Yeah, Adam, go for it.
I might jump in from my perspective. It touches on a little bit what we just talked about, but it's fairness and interpretability of AI. It's making sure that when the result of an ML or AI model is fair and even for all of the community. And this is really hard because the whole point of building a machine learning model is to bias it in some way. You're biasing it towards the predictive class, but you have to do it in such a way that you don't negatively affect a group of people. And this is one of the really challenging things. So it's imperative that users and developers of AI consider these ethical considerations from the top. They build in solutions to make that AI more interpretable and more explainable. And I think that's one of the biggest challenges we'll see in the coming years, and we will aim to solve.
Yeah, definitely very critical aspects that we need to consider. And I might go back to what I was discussing in my presentation, the trust challenge. It is basically a lot, making the problem a lot broader, but the thing is, we see people are getting more and more concerned about AI and what are the impacts. So if people don't trust the AI solutions, basically they will not use it, and that is basically losing the whole target that we had in mind in building those AI solutions. So it's important to have in mind what are those different dimensions that are driving trust. Some of them, as Adam mentioned, definitely the fairness, the bias, those aspects, but also we need to make sure we consider a all-round view, making sure, for example, we consider the security aspects, the ethical aspects, the legal side, and of course the technical side, which is the technical performance. So that is probably a challenge that we have in upcoming years, and hopefully we can gain that trust to AI systems.
Thank you so much. I think we're good to wrap it up all there. On behalf of everyone here, I'd really like to take a moment to extend a massive thanks to all three presenters today. You've volunteered your time, and your insights and advice are invaluable to students considering these pathways into the future. So thank you to Dr. Akbari, Dr. Makarucha, and Andrew. It was really good hearing from you guys. And we at Monash DeepNeuron would love to explore opportunities to meet and learn from you in future events, hopefully in a more in-person setting as well. So thank you so much. If anyone has anything else to say, let me know. Otherwise, free to log off there. Thank you.
Thank you.
Thank you very much,
Thanks
everyone.
for the opportunity.
Cheers.
Thank you.